Okay, this is A.REI.6 Algebra Reasoning with Equations and Inequalities 6, Video 5, Solving Special Types of Linear Systems. Here are a few terms I'd like you to copy down in your journals and define them. This video is basically going to tell you one of three things: whether or not a system of equations has one solution, no solution, or infinitely many solutions. And I'm going to gather your attention to the first one, called one solution. Now, we have worked at length on determining whether or not these equations have a solution, and if it does, what it is. So we went through a couple of different ways. The first one was graphing the two equations on a grid using this slope-intercept form for the two equations, and then seeing if they were to intersect at a given point. We would call that a solution. The second way, we use this idea of substitution. The third way of determining whether or not we have a solution was this process called elimination. And we use three different operations in the elimination. We used addition, subtraction, and multiplication when we were solving those particular problems. All right, now, there are special cases when there might be no solution or infinitely many solutions. So let's go take a look at those particular cases. Okay, one solution, I'm going to let you pause the video and use any of those previous methods of graphing, substitution, or elimination, and find out what that intersection point is, or the actual answer solution. And no solution. Now, this is brand new to us. Now, determining whether or not a system even has a solution, we are going to use this idea of slope-intercept form. So let me quickly just put them into form and then talk about it. All right. Now I've taken both equations and I've put them into slope-intercept form. And what I really want to focus in on is this idea of the slope being 1 for each one of these equations. Now, if you're thinking about a grid and you have two different y-intercepts, if I'm looking at the intercept of 2/3 and 4, those are the points in which your two lines are going to be intersecting for each of themselves. So looking at those starting points, I know that for line 1, my rise is going to be 1 and my run will be 1. And the same for my second equation. The rise is going to be 1 and the run is going to be 1, which means those two lines will never intersect each other, and we call this parallel. So if I'm going to paraphrase what I just said, by finding the slope of each line, if they are the same slope with different y-intercepts, these lines are going to be parallel, which means they're never going to intersect, which means they're never going to have a solution. All right, the last one is infinitely many solutions. Same idea. We're going to figure out what our slope is and then talk about it. So let me quickly do that here. Okay, that was very robotic. You guys are machines when it comes to solving these function forms and putting them into slope-intercept form. And I took it all the way down to a reduced look. And what do you notice about the slopes and the y-intercepts of these two equations? Good. You notice that the slope, m, is equal to negative 1/3, and that is going to be for both of them. And then the b, or the y-intercept, is negative 1/3 for both of them, which means these are identical lines. And if they're identical lines, they're one right on top of the other. We call that infinitely many solutions, which means every ordered pair will work in equation 1 and equation 2 at the same time. So every ordered pair on the line would be a solution. So they're all going to work. Infinitely many. Okay, in your journals, I'd like you to define the given terms on page 2 of the flip chart. Write a few sentences on what you learned from the video, and of course, write down any questions that you might have, anything that was confusing in here, and I will clean that up in class, and we'll work in our groups to answer all these questions.